This is a video from section 3.3. This is on derivatives of trigonometric functions. And let's go over the derivatives of the 6 fundamental trig functions. So we're going to start with 1. If y equals sine x, then the derivative y prime will be cosine x. Number 2, if y equals cosine x, now begins with c. When you take the derivative, you have to attach a negative sign. So y prime will be negative sine x. Number 3, if y equals tangent x, the derivative of the tangent is secant squared x. Number 4, if y equals cosecant x, begins with c, you need to attach a negative sign. And so y prime will be negative cosecant x cotangent x. Okay, these can all be proven, by the way. Number 5, if y equals secant x, then y prime will be secant x tangent x. And then lastly, number 6, if y equals cotangent x, then y prime will be negative cosecant squared x. Gotta know those basic derivatives before we embark on any type of example. It's just too important. And with that in mind, I want to take a moment and do some examples from section 3.3. And so let's start with example 1, and the directions are all to differentiate. So we're going to be just looking for derivatives. So if we have f of x is tangent x minus 4 sine x. And we want to look at f prime of x. Now, so let's go back. When I looked at tangent x and I take the derivative of the tangent, I get secant squared x. Okay, so the derivative of the tangent is secant squared minus 4 goes along for the ride, and if I take the derivative of sine x, you're going to get cosine x. And that would be the correct answer for example 1. Example 2. Suppose I had f of x is 2 secant x minus cosecant x. So if I want f prime of x, now remember that the derivative of the secant function is secant x times tangent x. So I'm going to take 2, the 2 goes along for the ride, and I'm going to multiply by secant x tangent x. And then I'm going to take and minus the derivative of cosecant x. Remember, it begins with a c, and so you're going to have a negative in there. So it's going to be negative cosecant x cotangent x. But you have 2 negatives next to each other, so that turns into a positive. And so, therefore, f prime of x is going to be 2 secant x tangent x plus cosecant x cotangent x. And that's how you do the second example. So let's take a look at the third example. Suppose I had g of x is 3x plus x squared cosine x. So I want g prime of x. The derivative of x is 1, and so you're going to get 3 times 1 plus. Now, I'm going to write down the first function, which is x squared. And what I'm going to do in parentheses is take the derivative of the second function, which is cosine x, right? So I got to take the derivative of cosine x, and when I take the derivative of cosine x, I get negative sine x. Okay? And then what I'm going to do is I'm going to write down cosine x, and then I'm going to take the derivative of the first function, which is x squared. And so the derivative of x squared is 2x, like so. And so when I go to simplify this, I get 3 minus x squared sine x plus 2x cosine x. And again, this is equal to g prime of x. And that would be how you do example 3. Let's take a look at example 4. Suppose I had y equals sine theta cosine theta. So this is a classic product rule problem. So when I take the derivative, I'm going to write down the first function, which is sine theta. I'm going to take the derivative of the second function, which is cosine theta. So the derivative of cosine theta is negative sine theta. So I'm going to write that here. And then I'm going to add cosine theta, and then I'm going to multiply times the derivative of the first function, which is sine theta, and the derivative of sine theta is cosine theta. So I'm going to put a cosine theta right here. So again, this is first derivative of the second plus the second times the derivative of the first. So you can think of this as first, second prime, right? Derivative of the second. And then you have the second times first prime. So it works just like this. And so y prime is equal to cosine squared theta minus sine squared theta. And I hope that looks familiar to you guys. This turns out to equal cosine of 2 theta. And that's how you do example 4. If we take a look at example 5, we'll put this one back in blue. So suppose we had g of theta is e to the theta times tangent theta minus theta. Suppose I want g prime of theta. Well, I'm going to take the first function, which is e to the theta, and I'm going to multiply times the derivative of the second function, which is tan theta minus theta. So if I take the derivative of tangent theta minus theta, I get secant squared theta minus 1. Okay? And then I'm going to write down the second function, which is tangent theta minus theta. And I'm going to multiply times the derivative of the first function, which is e to the theta. And the derivative of e to the theta is e to the theta. Okay? Now, I notice that I have an e to the theta common to both. So I'm going to factor that out. So I'm going to take an e to the theta out, and I'm going to write down secant squared theta minus 1 plus tangent theta minus theta. But this should look a little familiar to you guys. Secant squared theta minus 1 is tangent squared theta. So what I'm going to do is I'm going to replace that with tangent squared theta. And then I'm going to add tan theta and subtract theta. And you guys want to practice factoring out, because when you get to chapter 4, you're going to need to be able to find critical values. And so it will behoove you to be able to do that. Let's take a look at example 6. Suppose I had f of x is e to the x sine x plus cosine x. Now, I'm going to take the derivative, but on this term here, I'm going to apply the product rule. Okay, so when I take the derivative, so I'm going to write down the first function, which is e to the x, and I'm going to take the derivative. Let me replace that theta with an x real quick here. So when I take the derivative of sine x, I'm going to get cosine x. So I'm going to write down a cosine x. And then I'm going to add sine x times the derivative of e to the x, which is e to the x. And then I'm going to take the derivative of cosine x, because we still haven't done that yet. The derivative of cosine x is minus sine x. So I'm going to subtract sine x. And really, we're done, right? I mean, about all we can do is write e to the x cosine x plus e to the x sine x. And then I'm going to subtract sine x. And so all three terms don't have a common factor. And because of that, we can stop right here. This would be sufficient. And that's how you do example 6. Let's take a look at example 7. Suppose I had y equals cosine x divided by 1 minus sine x. And I want the derivative. So I'm going to take the bottom, which is 1 minus sine x, and I'm going to multiply by the derivative of the top. The derivative of cosine x is negative sine x. So we take the bottom times the derivative of the top. We're going to minus, and then we're going to take the top, which is cosine x, and I'm going to multiply by the derivative of the bottom. Well, the derivative of 1 is 0, okay? The derivative of sine x is cosine x. So we're going to subtract cosine x. And then we're going to divide by 1 minus sine x squared. So let's simplify this down a little bit. So I'm going to distribute the negative sine x inside. So you're going to get negative sine x. And we're going to add sine squared x. And we're going to add cosine squared x, right? Because a negative times a negative is a positive. And we're going to divide by 1 minus sine x squared. But sine squared x plus cosine squared x is the same as 1. So y prime is going to be the following. We're going to get negative sine x plus 1 divided by 1 minus sine x squared. But if we look at this straight, I'm going to get the following. I'm going to get 1 minus sine x divided by 1 minus sine x squared. And so therefore, y prime is 1 over 1 minus sine x. And that's how you would do that problem. Let's take a look at one more for this section. So we'll take a look at example 8. So let's take a look at this one. Suppose I had y is sine t divided by 1 plus tangent t. Suppose I take y prime. So I'm going to take the bottom function, which is 1 plus tangent t, and that's the bottom. I'm going to multiply it by the derivative of the top. The derivative of the top is cosine t. Okay? And then I'm going to go minus sine t, and I'm going to multiply by the derivative of the bottom, which is secant squared t. And then I'm going to divide by 1 plus tangent t squared. So if I simplify this down a little bit, you get the following. You get cosine t plus cosine t tangent t minus. Now, here, I'll write it down. We get to get sine t secant. Oop, here, let me erase that little part here. So we get sine t times secant squared t. And we're going to divide by 1 plus tangent t squared. Let's go to the next page. Now, let's take a look at a couple things. Cosine t tangent t is the same as cosine t times sine t over cosine t. But the cosine t's cancel, and you're left with sine of t. And if we take a look at that other one, sine t secant squared t, well, this is sine t times 1 over cosine squared t. And I'm going to pick off one of the cosines, and I'm going to write this as sine t over cosine t times 1 over cosine t. And so, therefore, sine t secant squared t is going to be the same as tangent t secant t. Now, let's go back. And so I'm going to have y prime. We'll come over here. We'll take y prime equals cosine t plus sine t, cosine t plus sine t, plus And then we're going to get tangent t times secant t, or secant t tangent t. So we're going to take secant t tangent t, and then I'm going to divide by 1 plus tangent t squared. 1 plus tangent t squared. And that's how you would do that 8th example. There's not a whole lot you can do with this, and so I would leave it just like this. And that concludes this video for section 3.3, and I worked 8 examples from the exercises. Thank you.